Hello, everybody, and welcome to a new episode and session of Talking Language AI, where we host talks and presentations and conversations about NLP topics, tools, and people. It is my great honor to be hosting David Adelani today. David is a research fellow and DeepMind academic fellow in the Department of Computer Science at UCL. He's a member of the leadership of Masakhane, a grassroots organization whose mission is to strengthen and spur natural language processing research in African languages for Africans by Africans. He was formerly a PhD student of computer science at the Department of Language Science and Technology in Saarland University, and his research focuses on NLP for under-resourced languages, especially African languages, multilingual representation learning, machine translation, and privacy in NLP. Thank you so much for joining us, Dave.
Thank you. Thank you for inviting me. Yeah.
Amazing. Really excited to listen to what you've prepared for us today. You know, this has been a wild time for NLP. There's so many developments, and the focus, every focus that can be and light that can be shined on, you know, how can we go beyond just focusing on English and focus on other languages. And improve multilingual tools is something that you know, we care very much about, as it enables a lot more people to use these tools. So really excited about having you to share sort of your work and what you've learned with us. Before we get into David's presentation, I'd like to, whether you're joining us live or you're watching this on YouTube, I'd love to invite you to the Cohere Discord. You can sign up. There's a link in the chat or in the description where you can join, but there's also a thread for this particular talk where you can ask questions, and we'll continue to monitor it and continue to have a conversation about it. So feel free to ask any questions there, so we can you know, continue to have that conversation well beyond just the live session. With that, I'm going to hand it over to David to start his presentation today.
So thank you once again for inviting me to give this talk. I'll be discussing my research on natural language processing for under-resourced African languages, and I'm going to be also talking about our community, Masakhane community, because we have worked on this topic together in the last 2 to 3 years. So as I've been introduced, I'm a research fellow at University College London. So if you come to London, you can say hi to me. So first I will start with what we all know about the progress of language technology in English. We all know about ChatGPT, GPT-4, and recently by Google, Bard, and every other company, they release some language model or the other. But what are the kind of data sets, or what is this ChatGPT trained on? Most of the text that ChatGPT is trained on, just by interacting with it, you can say it's mostly English text. And of course, you can ask a question to ChatGPT, for example, like how to prevent COVID-19, and it gives you interesting results like wear a mask, wash your hands regularly, avoid large gatherings. But what happens if you try the same query in a West African language like Yoruba? Interestingly, I was surprised to see this result, that if you ask the same query in Yoruba, it's also able to give you good answers, but in English. And you know that there's some interesting cross-lingual retrieval going on, because you ask a question in Yoruba and it's giving you the reply in English. Then I further asked ChatGPT to interpret it to Yoruba, and then it gave me garbage. You know, it just gave me like, if you try to translate, the second sentence is like, take white feather to their horse, which doesn't mean anything useful. So the translation is incorrect and meaningless. So that means this technology most of the time doesn't work for under-resourced languages. But the question is that what if this language technology is needed? Because some people can say, it's okay if it supports some languages, but what if at critical time, for example, when there was COVID-19, there was a sudden need to translate basic health tips for many people, people that speak several languages. What if they do not speak English or other high resource languages? How are we going to communicate with them? How are we going to pass important information to them during this pandemic? And actually, this is a BBC article covering our work on May 20K, which is a multi-domain English Yoruba corpus for machine translation and domain adaptation, because we're trying to see how machine translation can work for a new domain, including medical domain or COVID health tips domain. So it's important to work on other languages because it's important to access information in these under-resourced languages. Think about people that this is the only language they speak and they cannot access information. It's like you're saying Google search is not for them because they do not communicate in any of the high resource languages. It's also important to enhance human communication. Think about machine translation. I lived in Germany for a few years, and when I first got there, I was not able to understand the letters coming to my apartment or the bills, just because I don't speak German language. But with this technology, you could benefit from something like Google Translate to automatically translate the reports coming to your apartment. But this kind of service is not available for many under-resourced languages. This is also important to enhance voice interaction systems that most of the core technology that this is based on is like text-to-speech, speech-to-text, like speech translation, and dialogue system. And this has a lot of potential in education, to tourism, to business, to humanitarian responses, very critical applications. And it's also important to understand the linguistic structures of various languages. Maybe we could save some from dying because we do not want these languages to die. So the linguists will call it like language genocide because we don't want these languages to die. It's important because not many languages benefit from NLP. We have over 7,000 languages in the world, according to Ethnologue. And over 400 of these languages are spoken by over 1 million speakers. But on the right-hand side, if you look at the distribution of the languages, you find out that many of these languages are concentrated in either Asia or Africa. So which shows that many of these languages are, but in NLP research, most of our concentration is based on the European languages, which is just like a tiny portion of the world languages. Also, according to Ethnologue, many of these languages are endangered, over 40% are endangered. Only 7% can be categorized as institutional. They are institutional because they are often used by government, schools, or mass media, and even less are supported by language technologies. So how can we define under-resourced languages? So it can be defined as languages with less resources. Looks trivial, but these are languages that have less resources in terms of unlabeled data or labeled data. Unlabeled data in terms of how much web presence does this language have? A language that is often used on social media or that is often used on the that have like news resources or many resources on the web, actually they are less to be regarded as under-resourced. Also in terms of the amount of labeled data sets you can use to solve a task, do you have sentiment corpus, classification corpus in this language? And we could also categorize it in terms of research that has been done on these languages. How many NLP models have been built for this language? Do we have representation models for this language? Do we have multilingual representation model like multilingual birds for that language? Does it support that language? Do we also have task-specific models? For example, do we have machine translation tools supporting that language? And some languages are even in a more terrible situation because they do not even have basic linguistic tools, such as keyboards, spell checkers, morphological analyzers, and dictionaries. Interestingly, there's a nice connection between the amount of research that has been done on the language and the amount of data that is available in that language. So the more unlabeled text you have, the better the representation models you can build. And in general, the representation, the amount of research that has been done on this language is also a reflection of the serious societal issue, because we often have authors coming from these underrepresented communities. They have less publication in these top conferences. So because of that, there's also less focus because there's lack of representation of people from these communities to work on these languages. And if you look at the number of authors with an African affiliation, in 2021, only about 12 have an African affiliation, which is just like less than 1% of publications in NLP in 2021. So the most commonly used kind of classification is based on Joshi's work in 2020, where you could categorize languages of the world based on their unlabeled corpus and labeled corpora from class 0 to class 5. Class 0 are typically languages with no unlabeled text, which covers like 80% of world languages. And class 1 are languages with some unlabeled text, but they do not have labeled text. And we also have class 2, 3, 4, and 5. And class 5 can be referred to as winners with a lot of labeled data and a lot of unlabeled data. And this is the typical situation for English, Spanish, Chinese, and Arabic, and a few others. But most of the under-resourced languages are between class 0 and class 2 because they have less text for labeled data set and unlabeled data set in general. So in terms of NLP research, not all languages are treated equally by researchers. In terms of the number of publications, if you extract the publication from ACL ontology, you find out that many of the languages that are being covered in literature often covers like English, a few European languages, and a few Asian languages like Japanese, Chinese, or Arabic. Well, if you look at the amount of languages that we have in the world, you will find out that the most covered languages does not reflect the true distribution of the world languages. We have more languages in Asia and Africa, and less attention has been paid to these languages. Why do I focus on NLP for the resource languages? Number one, many of this is the second continent with the highest number of languages apart from Asia. Number two, in terms of language family, is very diverse. You have Afroasiatic family in the northern part of the continent. We have Nilo-Shararan in the central, eastern, and some part of the western part of the continent. We have the Niger-Congo, which is like the largest language family in the world. We have the Khoisan family, Indo-European, and Austronesian in Madagascar. Apart from that, these languages are spoken by a large number of people. One of the things that really encourage people to build language technology for European languages is because these languages are spoken by a lot of people. So there's need to actually build language technologies for them. The situation is very similar to African languages because they're spoken by thousands and even millions of people, compared to like Asian languages, where you can have some languages with very few number of speakers. So you can agree with me that this is quite important to focus on NLP for African languages because this concerns over 1.5 billion people. And these languages are underrepresented in NLP because of lack of data set for training and evaluation. Also, we have weak language policies by many African countries because they do not really push for these languages to be used in their countries. Also, there's lack of compute for developing NLP models, and this is quite critical now because current models actually requires a lot of compute, even for evaluation. And also there's limited coverage of these languages in multilingual representation of language models. So what do we do typically in NLP today? We start by training by doing what is called self-supervised retraining, where we train on a large amount of text, and then we could train a word-to-vec model or a BERT model or a T5 model, and then we can now fine-tune on some few examples, maybe with an additional architecture like LSTM or a simple linear layer on top. And then we can then use it to solve a classification task, like sentiment classification or question answering. But in terms of the African languages, all these different parts are broken. First, there's lack of labeled data sets to even fine-tune this multilingual representation model. So there's no large enough unlabeled data that you can even use to train a very powerful encoder to encode the information in this from this unlabeled text. So the only thing we can leverage is what is called transfer learning, assuming that this model that has been trained on so many languages, can we adapt it to a new language, even if it's from Africa? The third point is lack of compute to run them. And this is very critical, especially if you are running a model using an academic GPU. And if people in Europe are even struggling in academic about compute, you can imagine the situation in Africa, many African labs. So because of this, how do we address some of these challenges? For the lack of data for downstream tasks, we actually use what is called participatory research, where we try to see how can we develop labeled data sets using participatory research. The idea is involving the communities that are speaking this data set, that are speaking these languages in the development of this data set and building models so that we can all solve the problem together. The second approach is that when we do not have large enough data, are there ways where we can adapt the original language models for our languages? And I'm going to discuss one approach called multilingual adaptive fine-tuning, where we use to adapt an existing model, multilingual model, to other African languages. Basically, we're specializing it for African languages. So the part one of my talk will be on how do we address the lack of labeled data set. And I'm going to talk about our data set called named entity recognition data set for African languages. And this is based on two publications. One is a TACO, a journal paper, and the second one is as EMNLP 2022, where we expanded the data set. So first, let me introduce the task of named entity recognition. It's a core task in information extraction, and it involves recognizing entities. It could be like personal name, location, organization, or date. And an example is on the right-hand side, where you could identify 4th of February as the date. But here we're interested not just getting it correct, getting a single token correctly. We want to get the entire span correct. So 4th of February should be fully identified before we can say the NER model is able to recognize 4th of February. Also, global voices can be regarded as organization or Fernando Gomez as a person. And like I said, this is a token classification task, and the evaluation is typically done using F1 score. So in terms of developing labeled data set, when I started working on this space since 2019, the data set that are available are very few. I think we can say that we only have like maybe WikiANN, which covers like 9 African languages, CMU Wilderness Corpus that covers like 30 African languages, and some other labeled data sets that are available are probably just offline or you have to pay for them. But in 2023, we have several data sets like NAR for part of speech, news topic classification, machine translation, sentiment classification, Bible TTS, and all these data sets were created in partnership with Masakhane organization. So what happened between 2019 and 2023? There are some initiatives. For example, we have this ZindML competitions, which was trying to address the issue of lack of data set by encouraging researchers to bring out their data and so that they can run machine learning competitions in different African universities. So this initiative was started around 2019. It was quite useful to encourage many Africans to come into AI. And also we have Africa NLP that is organized by Masakhane. And this started around 2020. And most of the papers that are published in Africa NLP actually address the data issue. Some introduce a new corpus for African language for several languages. Our Masakhane community has been at the center of this because they are the one that organized the Africa NLP workshop. And surprisingly, it was during the Africa NLP workshop in 2020 that I also joined Masakhane, just because of the amazing work they are doing on the continent. We also have some funding organizations like AI for Deaf formed, which is a partnership between, for example, IDRC in Canada, GIZ in Germany, and I think there was one Swedish organization also that was trying to encourage, basically providing funds for researchers to create data sets. And similar to that is Lacuna Fund, which also has several organizations like Rockefeller Foundation, Google, GIZ coming together to also fund language data sets in Africa. So let me talk more about Masakhane. Like I said, it's a grassroots NLP community. So the idea is let's take ownership of the problem. It's our problem, let's solve it together. So it's a community for Africans and by Africans. So it's pioneer participatory research. Let everyone's contribution is important. If you're a linguist, you can contribute. You're a native speaker, you can contribute. Basically, we want to lower the entry point into research for people from our community. And they organize, we organize like Africa NLP workshop every year at top ICLR conferences. So this year we're going to have Africa NLP workshop at ICLR, which will happen in Kenya, the first time in Africa. And we have a very active Slack community. And through the partnership with Masakhane, we developed the first large NLP data set for 10 African languages. So let me just give an overview of the data set, and I'll move quickly to the models and the results. So in terms of the data set, why did we decide to do this? We do have some previous annotated data sets like WikiNN, but the problem with this data set is that it was automatically annotated. So the quality is quite poor, and also the number of tokens that were there was quite small, like less than 1,000 tokens. So another data set that is available is the Sadila data set. This is based on government data, but this is only for South African languages, and the government data doesn't actually adapt very well to other domains of interest. We have the Lorelei program, which is, I think, a data project in the US. But at the end of the project, they did not publicly release the data set. So if your academic institution have a partnership or subscription with LDC in the US, you can download the data set. But the data set was annotated for Africans, but Africans do not have access to this data set. And then we decided to change the story. Basically, we create our first NER data set, and we also make it public to everyone that other people can benchmark their work on our data set. And this was annotated, at least the first version was annotated by volunteers and native speakers from our community. And we have very high inter-agreement score of around 0.96. Looking at the Flex Kappa score, we are like minimum of 2 annotators per sentence. The MasakhaNER project actually involves different stakeholders, including native speakers, linguists and language experts, NLP and machine learning experts across the world. And we have like many of the researchers are from Africa, which are our annotators. We also have like researchers from the US and Canada, also researchers from Europe and from Asia. And I was privileged to lead this effort across like 62 other researchers from around the world. So the Masakhane project has two phases. The very first phase is what we call the Masakhane 1.0, which covers 10 African languages. And the data set is a bit small because this was based on voluntary work. And I'm going to tell you some of the limitations of our participatory approach. We are able to annotate mostly data set from West Africa and East Africa. So we actually do exclude some regions of Africa, but after the completion of our work, we find out that some regions we have excluded actually have some interesting linguistic properties. And we find out that it's difficult to transfer from an NER model trained on the West African languages to, for example, languages in the southern part of Africa because of difference in the language characteristics. So we decided to expand this to cover some more West African languages and Southern African languages, where we cover Shishona, Setswana, isiZulu, and isiXhosa. So the second part of the project covers like 20 African languages. And the major difference between the first one and the second one is that the second one covers more languages, and also the data set is larger. So we could perform other experiments on how increasing the data size actually improves the performance. So let's talk about some of the language characteristics of African languages. And interestingly, some of these characteristics also are present in other regions of the world. Number one is that imagine training an NER model on English. How would you adapt this to Amharic? The first challenge you're going to face is that Amharic uses a different script. And there are some differences between how these two languages. Apart from the scripts, there is no capitalization in Amharic. How will you be able to adapt like NER model? And one of the important features is capitalization. And capitalization is not in Amharic, and it uses a different script. So this poses some challenges. Other challenges are morphology. So Bantu languages have rich morphology, and maybe an affix or affix is often appended to the root word. And actually, this might makes it a bit difficult to adapt an English NER model to Bantu languages. We also have languages that actually, apart from having rich morphology, they also have noun classes, like isiZulu, where you have a prefix attached to the root word of Kano. In this case, you have what is called like Wisikano. And actually, this affects the transferability of an English NER model to isiZulu. Why? Because you have capitalization in between a word. And actually, this affects the transferability of an NER model from English. So also we have languages that make extensive use of diacritics, which is like accents on top of the words. So what are some of the challenges of this participatory research? Of course, it's a very good solution, but also there are some challenges. One approach is that, at least for Masakhane 1.0, is that when I was doing this project, there was some language barrier. I don't speak French, and I had to coordinate like projects in some communities that speak French. And 21 African countries actually uses French as their official language. So we had to look for bilingual speakers that can actually run this project in their different communities. Also, there are some challenges of working with non-Latin script because you have no idea what's going on. It's difficult to verify the accuracy of the work. So, but that means we have to engage with the language coordinator to ensure he's doing the right thing. The third one is that participation is often for a short time, because when you work with volunteers, at some point they can be engaged with other activities. So if you engage them for a very long project, they may just like drop off of the project. So maybe you can, from my experience, maybe you can only engage them for maximum 2 months before they get tired of the project. So you have to really structure your project that you can achieve something tangible within a short time, for example, 1 or 2 months. Another challenge is that the output is often small because their volunteers, they can only work, they have other things they're doing. So you only prioritize maybe small amounts of data to be annotated and look for what you can do with this small annotated data set. But this small annotated data is better than nothing for these under-resourced languages. So one approach we have adopted in Masakhane to further encourage annotators is to also add them as authors of the paper, and that's why we have this large author list. And this we have seen to be highly encouraging for people in our community. So in terms of the model building, we make use of our standard NER model, like CNN by LSM CRF model, which is like the state of the art before the pre-trained language models. And also we fine-tune like massively multilingual models like Multilingual BERT or XLM Roberta or on these languages. But looking at our languages, we found out that only 2 or 3 languages are supported by this multilingual pre-trained model. So one way to improve over this is what we've known as we have called language adaptive fine-tuning. That means if you take an existing multilingual BERT model, you can further adapt it to a new language by fine-tuning it on monolingual corpus of that new language. Some people refer to this as like continued pre-training, but additionally, you could also modify the vocabulary because, for example, if you want to do this, apply this approach to Amharic, you are going to have a problem because multilingual BERT does not support the Amharic script. So first, you need to find a way to integrate the Amharic script into the tokenizer, into the vocabulary before this approach works. And then you can now fine-tune this on the NER task. So we introduced this approach in our LAFT paper in 2020. And also people have adapted this to new domains or to new tasks. And the popular paper you might know will be Don't Stop Retraining. And you can easily adapt the same setup to new domains and new tasks.
Can I ask a quick question, David, on that previous slide? So here, is this a 2-step sort of training? So multilingual BERT, and then I'm assuming you're extending the tokenizer, right? Like not replacing any of the existing tokens, but you're adding more tokens to represent the Amharic. Is that correct?
So actually here, we actually replaced it. So there are 2 ways you can extend or replace entirely. Actually, I've tried both setup and it looks like just extend is simply extending actually has slightly better performance than completely replacing the vocabulary.
Okay, and then is there a masked language modeling step between the two, or
yes, exactly. So this from MBERT to Amharic BERT, you use the same objective. Basically, you use the same objective as the original multilingual BERT model, which is next sentence prediction and max language model.
Okay, so the same 2 sort of tasks that BERT does, and then it's fine-tuned on the NER. Okay, that makes
exactly, sense. And then you fine-tune on the NER task.
Wonderful, thank you.
I'm looking at the results. Let's just look at the baseline models. One thing you can see here that normally you expect multilingual, you will expect multilingual pre-trained language model to be better. But in the case of Amharic, the original multilingual BERT doesn't support it, and we have an F1 score of 0. Just because the vocabulary, if it's not supported, the tokenization fails. So for a language like Hausa that was originally supported by XLM Roberta, it gave better performance than multilingual BERT, for example. And so that means language inclusion in the original pre-training is important. And we find the similar thing for Yoruba, that multilingual BERT included Yoruba in the pre-training, and it has slightly better performance than XLM Roberta, because XLM Roberta doesn't include Yoruba in the pre-training. But on average, if you exclude Amharic because it has this tokenization issue because the script wasn't supported. There's no big difference between either using Multilingual BERT or XML Roberta, because you could benefit from what is called this transfer learning to adapt to even African languages, even though they have not been seen during pre-training. To further improve over it, our result shows that by applying this LAFT approach, we can significantly improve the performance. For Amharic, we jumped to 60 from 0 to 60% because we changed the vocabulary followed by this fine-tuning on Amharic corpus. And for Kinyarwanda, we are able to also improve the performance, even though it was more morphologically rich. And we also try for Wolof. In the case of Wolof, we only had very small amount of data, so I wasn't sure if it will work. So, but surprisingly, the largest corpus for Wolof was the Bible, and we still had like impressive performance. So that means any data, any monolingual data you have for a language is important to further adapt it for the downstream task. But if you compare the performance of the LAFT training to the XLMR Roberta, you'll find out that for Amharic, XLMR base had better results than Multilingual BERT plus LAFT. And the reason is because XLMR has already seen Amharic during pre-training. So which shows that the LAFT approach is powerful, but actually it doesn't work very well if the original script is not seen during pre-training. So the lesson is that it's important that when we are training this multilingual pre-trained model to try to cover as many scripts as possible so that it's easy to adapt to a new language in the future. So we also try with this zero-shot transfer on Masakhane. And the question we are asking here is that what is the best language to transfer from? Should you always transfer from English? Most times we try to transfer from English. Why? Because it has the most available label data set for any task in the world. But the question is that we found out that it's better to transfer from a linguistically related language or a geographically related language in the case of NER. So, and this is interesting because if you transfer from English NLP data set, it has over 14,000 examples in the training set. The performance is much worse than transferring from Swahili or Hausa, which has like less than 1,000 sentences in the training set. So this shows us that linguistic relatedness of these languages, because they are also African languages, and also their geographical closeness. And one way to imagine this would be you have more, let's say, African entities that are being shared between these languages. Maybe they are talking about the same president, the same location. This helps the transferability than just using an English language that is talking about some other European entities. So another last experiment we did on this is how does Masakhane 1.0 transfer to Masakhane 2.0? We created 2 data sets. And the reason why we wanted to check this is that it's good we are working on African languages, but we also need to work on typologically diverse African languages. We found out that if you train on Masakhane 1.0 and evaluate on Masakhane 2.0, comparing to training on Masakhane 2.0 and evaluating on the same Masakhane 2.0, the performance looks very okay. Why? Because for languages already in Masakhane 1.0, the only difference is that you increase the size, the training examples in Masakhane 2.0. So the performance is okay, more than 70%. But if you do the evaluation on languages not in Masakhane 1.0, you will find like a huge drop in performance. And why is this? Because languages in Masakhane 1.0 have some very different characteristics from, for example, the Southern Bantu languages in South Africa and in Zimbabwe. And one of the features is these noun classes. So they have noun classes and morphology, and the idea is that they have capitalization in between words. So in West African languages, you will just have an entity Kano, But in the Xhosa language, they have like a prefix before canon, which makes transferability harder. And the lesson is that when we are developing data set for African languages or in other regions, we should try to cover typologically diverse languages in our benchmark data set. This is important if we want to adapt to new languages. And also in this work, I've also talked about our approach of doing research, which is about participation research in involving people, native speakers, and linguists, and other researchers in developing benchmark data sets and developing models for African languages. So that's the first part of my talk. Then I will quickly go over the second part, but you can stop me on the way if you have questions. Okay, for the second part, how do we address the second challenge? We already talked about some of the challenges of using an existing multilingual portrait model. The second part is how do we adapt an existing multilingual portrait models to African languages? And this is based on our Colling paper, which also got the best paper award at Colling. And let me start with some of the challenges of adapting portrait models to African languages. One major challenge is limited language coverage in portrait language model. So what we have seen is that for languages that are included during pre-training, the performance is often higher than languages unseen during pre-training. And this is related to what is called cost of multilinguality. That means you cannot cover all languages in a single encoder model, like a BERT model. So if you intend to cover more languages, you also need to scale the capacity of the model. And even if you have the compute to scale the capacity of the model, we are also faced with non-availability of corpora to train on. And that's why most pre-trained language models often limits the number of languages to about 100 languages. Another challenge we are faced is this hardware restriction, which means that pre-trained language models are getting bigger and bigger. Of course, they're getting better as they get bigger, but fine-tuning them and deploying them is a big issue, especially for people from the other resource community. So in this talk, I will just try to address the first part of the talk. For the second part, you could go check our Colling paper for more information. One of the best way to approach this limited language coverage is what we have described in the first part of the talk, which is this LAFT training. You can adapt the original encoder, multilingual BERT, by fine-tuning on a monolingual corpus of another language. But there are limitations for this. Number one, it's difficult to adapt for non-supported scripts because the performance will not be as good. Number two, this LAFT approach creates a copy for every language you try to adapt to. So if you try to do this LAFT training for 20 languages, that means you're going to duplicate the multilingual BERT model for 20 languages. And this is not parameter efficient. And this also limits the cross-lingual transferability. Once you have adapted it, for example, to the Amharic language, it's difficult to adapt it again to another African language. So there are several ways to address this. The first approach would be, okay, you can just pre-train on more languages. Pre-train on more languages, and this is what Ogweji did in 2021, but this is resource intensive in terms of compute and data requirement. The second approach would be to use a more parameter efficient approach like adapters. The idea is that you can add a small component to the transformer model, to every layer of your transformer model, and you only fine-tune this added parameter instead of fine-tuning the whole entire model. This is more parameter efficient, but you still require this adaptation for every language. So you need to store parameters for every single language you are adapting to. So what we have done in the case of African languages is that you can just specialize this multilingual model to a group of languages, and we call it multilingual adaptive fine-tuning. Instead of doing this adaptation to one language, why not do it to several languages at once? And that's why we call it multilingual adaptive fine-tuning. And we were inspired by what was done for multilingual BAT. The initial multilingual BAT covers 25 languages, and then they trained on those 25 languages and additional 25 languages to have what is called multilingual BAT 50. But the difference between our work and theirs is that they try to extend multilingual BAT to 50 languages, but we are trying to specialize our multilingual model to African languages. And that is a slight difference in our work. And for this,
David, can we sorry, just can we just talk a little bit about the difference there?
Okay, sure.
So extending versus focusing, is the one that is focused is it's okay if it sort of forgets or does worse at languages that it knew before, but didn't know again. Is that correct?
Exactly. So for the case of Afro-XLMR, it might forget some languages that that are not used in Africa. For example, for the Afro-XLMR training, we didn't train on Portuguese, so it's going to forget some part of Portuguese. Okay. But in the case of the MBAT 50, actually they try to see how they can retain the performance of the original 25. And for them to retain the performance, they have to train on both the 25 languages and the additional 25 languages.
Okay.
So that's the difference.
And the hypothesis there is that you can use more of the parameters of the model to just focus on the targeted languages instead of
exactly. Yeah. So our approach is more specialization to the region of Africa. Yeah.
Okay. Yeah, that makes sense. Thank you.
And for this, we have to pay attention to some things. What is the best preaching language model to adapt? So, like I said, we will not be able to use multilingual BERT. Why? Because it doesn't cover some scripts that are used in Africa, like the Amharic script. So we decided to go for XLMR because it covers all the major scripts, Arabic, Latin, and GI scripts used for Amharic. Also, for the languages, we decided to include English, French, and Arabic because we want to retain cross-lingual transferabilities of these languages. And why are these languages important? Because they are also widely spoken in Africa. English, French, and Arabic. Throughout the North Africa, Arabic is spoken. So we can use this to adapt from this language to other African languages if there's some label data set in these languages. And the corpus we fine-tuned on is the MC4 corpus that was used to train the MT5 corpus and the news corpus. And with this, we're able to expand to several regions of Africa, to languages in several regions of Africa, more than AfriBeta that was trained from the scratch. So looking at the results, first I'm going to tell you looking at the result because we're trying to compare the original XML-based model to the LAFT approach. And in this work, we look at the LAFT approach as a stronger baseline. But the LAFT approach, the difference is we have to train on monolingual corpus of each language and have a different model per language. And as I've said, LAFT approach actually gives better results than the XML-based result, as you can see. And on average, it's also better. But we find out that it doesn't help for English. Why? Because English has been seen a lot during pre-training. So further adaptation actually hurts the performance rather than improving it. Then we compare the LAFT with MAFT. And as you can see, our approach is able to almost maintain the performance. It's quite competitive. You will notice some drop in performance, for example, for Amharic. And for Wolof, this is an interesting case because Wolof was not part of the MAFT training because it doesn't have up to 50 MB of data. And for the LAFT training, we had to train on monolingual text for Wolof, but for the MAFT training, we didn't. And still the performance are quite similar. So that means our approach is quite interesting because it adapts to new languages that even are not seen. during pre-training. So I would say we're slightly a bit disappointed that we are not able to match the performance one-to-one, because our idea would be we just want to have a single model. But one thing we did was to scale this approach. What happened if we scale, instead of training on XLMR base, why not train on a bigger model? And the two languages that had worse results are Amharic and Yoruba. But when we scale to a bigger model, surprisingly, we are able to have the same performance for Arabic and even better results for Yoruba. So that means we're able to achieve our aim. We have a single encoder, multilingual pre-trained model that have similar performance or better performance as the LAFT approach. And actually, that saves a lot of space. That means you don't have to store different model for different languages. You just use one model. And that model is able to adapt very well to new languages. And we tested this Afro XMR large, and actually it achieves the state of the art across different tasks, even better than some of the best encoders, multilingual encoders like MD Beta version 3 that recently came out at ICLR. Our approach did very well for sentiment classification, for NAR and news topic classification. Also, we have open source our model, and last month actually received a lot of downloads when they ran a shared task for sentiment classification for African languages. The winning team actually used our model to win the competition, and we're really excited about this, that the community found it useful. We have also applied this MAFT approach to machine translation, where we did this adaptation for sequence-to-sequence model. And here we adapted multilingual T5 to Afro MT5. And we published a paper called A Few Thousand Translation, Go a Long Way. And the idea of the project is that how can we leverage pre-trained models to adapt to a new domain? And here we claim that by using few parallel sentences, few thousand parallel sentences, like 2,000 parallel sentences, you might be able to create a useful MT system for other resource languages. And when we compare adapting MT5 and Afro MT5, you can see that actually we can significantly improve the performance, which shows that this MAFT adaptation, although quite simple, is quite effective for under-resourced languages. And this is a summary of my talk, where we try to tackle the major challenge of adapting pre-trained language models to under-resourced languages, and we propose multilingual adaptive fine-tuning to address this challenge. In conclusion, we address two major challenges of building language technologies for under-resourced languages. One is lack of labor data set, and the second one is limited coverage of these languages in multilingual representation learning models. And we introduce participatory research as an effective way to address the first challenge, and introduce multilingual adaptive fine-tuning to specialize multilingual representation models to African languages. Thank you.
Amazing. Thank you so much, David. That was, quite a bit of coverage across topics. I thought you explained the motivation really well. One point in your talk that sort of was really interesting for me that I'd love to pick your brain on. So in order to create great systems, great NLP systems that serve these languages, there was this need for data. Because the data wasn't there. And then in order to create that data, there was this need to create community. I love how you related it back to people. Curious to hear more about Masakhane from you, sort of, how it started, its activities, and how can people sort of get involved with Masakhane, or how can people maybe in other communities who don't feel the tech is serving them enough start their own sort of organizations? What things works, or what tips are there for people who can either contribute to Masakhane if they're in Africa, or people in other communities who are interested in support for their own languages?
Yeah, that's a great question. Surprisingly, I didn't start immediately with Masakhane. I only knew about the organization in 2020. So it was founded, I think, there was another event in Africa called Deep Learning Daba. So during this event, Deep Learning Daba, they had a discussion about importance of language in Africa, and they started Masakhane. Key people there would be Jade Abbott and Bukosi, Marivate from South Africa, and some other people came together to start it. And when the community was growing, after the Africa NLP workshop in 2020, that's when I actually joined the community. But I was privileged to lead the very first data creation effort in Masakhane. So initially it was more focused on machine translation models. How can you build your own machine translation for your language? And then it expanded more into NLP. I started from the NEL project. And the interesting thing is that anybody can contribute. We welcome researchers from all over the world. We have collaborated with amazing researchers from tech companies, big tech companies, and different universities in the world. If you look at our author list, you will also find their names there. And we have also worked with collaborators from different regions of the world. In our first Masakhane project, we would have an author from India, and we have, so we are not kind of restricted. So it's not that the only people there are Africans. No, we collaborate with people from around the world. There's something you can contribute, and we'll be happy if this can be replicated in other regions of the world. Like I always tell people, if you want to solve a language problem for your language, you only need a serious language speaker, just one. Because in the first Masakhane project, there was one lady I was trying to convince. She's from East Africa, and wanted to create any other data set for Swahili. We are not able to find someone. And she insisted that she wants to work on Luo. I was like, why not work on Swahili, which is a big one? She said she wants to work on Luo. And because she was really very adamant about this, it was a success. Luo was part of the NER data set we created. And we even had like annotators for Luo before Swahili. That is a big language. And recently we also have someone that was just passionate about Shivenda in South Africa. And it was from another field completely. I think he was working on climate or something. But he wanted it, and he collaborated with other researchers, NLP researcher, and was able to achieve his aim. So that means if a single native speaker is interested in making it happen, a community like Masakhane, it can get a lot of support from them. You just have to show them and say, oh, I have this problem. I really want to do it for my language. Can you help me? And people will gather to help the person.
Amazing, thank you. We'll post links to Masakhane. I'm assuming there would be like an application or a join us button somewhere on the website for people who are interested to join.
Yeah.
One final question is from one of the participants is like, can this, what we learned in this session, can it be applied in low resource Asian languages as well?
Absolutely. For example, I talk about the script issue, and there's no other place where you have script issue more than India, because like every language has its own script. I guess if I don't happen to overgeneralize, and some of these issues they're gonna be they will face it. How can you adapt from, let's say, a Latin model to other languages that uses a different script? This is quite valuable. Also, a model of creating data sets, I think, can be applied where you work with these different communities to work on data set creation. Yeah, there have been a lot of interesting work coming from India. For example, I know about this Indica stream data set that was created quite recently, where they also try to create some new data set. Yeah, I think that's really great work.
Amazing. I think this is all the time we had. Thank you so much, David. That was a really great sort of exposure to all your work. We'll be posting links to David's Twitter account where it can be reached, and we welcome people to continue to ask questions in the Discord and join us. Thank you, everybody, for joining us. Thank you, David, for enlightening us. And see you, everybody, in the next one. Thank you.
Thank you very much for the invitation. I really appreciate it. Bye.